Now we want to start looking at horizontal and vertical asymptotes from the limit perspective. This should be very intuitive if you have worked with the asymptotes previously and are pretty familiar with them. So I'm going to start by doing a quick review of this so that we're on the same page, and then we're going to work through this. So first of all, let's write off to the side here. Oh, I'm still green. I want to be blue. There we go. F of x is equal to x plus 2 times x minus 3 all over x minus 3, x minus 4. Now, when you're looking for the vertical asymptotes, you are looking at for the factors that don't cancel. Because you want to know, where does the denominator equal 0? The second part, how do you find holes on the graph? You're looking for the factors that cancel out. So as I look at the first one here, I can see the x minus 3's cancel out. So you have a hole at 3, comma, and then you plug the 3 back into whatever's left over. So f of 3 is going to be 3 plus 2 over 3 minus 4. 5 over negative 1, which is negative 5. So your hole is at 3, negative 5. The vertical asymptote then are from the factors that do not cancel. So that x minus 4 did not cancel, so then x equals 4 is a vertical asymptote. That x plus 2 at the top in the numerator, if you think about what negative 2 is, that would be the y-intercept, where the graph crosses the y-axis. Because you would set x equal to negative 2, and then when you solve that out, it would be equal to 0. So I should say it's the x-intercept at negative 2, not a y. So then the definition of vertical asymptotes, we can look at these from the limit perspective. The vertical asymptote at x equals c would occur if the limit as x approaches c of f of x goes to plus or minus infinity. Which you know that from previous experience, that if you were to look at your graph like this, you'd know that there'd be a vertical asymptote here as you headed off to infinity. So here the limit as x approaches 0, you'd be looking at positive infinity on both sides. So there is a vertical asymptote there. The second piece are horizontal asymptotes. Horizontal asymptotes describe the end behavior. The end behavior. How do you find the horizontal asymptotes? You compare the numerator and the denominator's powers. And the idea of the definition of a horizontal asymptote is you get a horizontal asymptote at y equaling the limit if the limit as x approaches infinity of f of x equals L. So as you go off to infinity, and it could be plus or minus, let's put that down, plus or minus infinity, going in each direction, you're going to have a horizontal asymptote. So the idea of that would be, if I had a horizontal asymptote right here, if my graph went like this, the limit as x approaches positive or negative infinity would be that horizontal asymptote. You're getting closer and closer to that. So looking at example number 1, f of x equals 1 over x. We get a vertical asymptote at x equals 1. We get a horizontal asymptote at y equals 0 because the degree of the numerator is smaller than the degree of the denominator. So that'd be y equals 0. And if I were to draw a very quick sketch of that, vertical asymptote at x equals 1, horizontal asymptote at y equals 0, and then we've got our normal rational function. So as I evaluate the limit as x approaches 1 from the right of f of x, I can see we have a positive infinity, goes down, or up forever, I should say. As x approaches 1 from the left, we go down to negative infinity, because as we approach from the left-hand side over here, we're heading down. And then as I look at the limit as x approaches infinity of f of x, we get 0. Because we continue all the way over here as we get closer to infinity, which is forever. It's getting closer and closer to 0. And if I get closer and closer to negative infinity here, we're also going to be equaling 0, which is the horizontal asymptote. So the idea is that a vertical asymptote occurs if the answer to your limit is plus or minus infinity. You're going to have a horizontal asymptote if the plus or minus infinity is what x is approaching. So that is the difference between the two. If your answer is plus or minus infinity for a limit, you're looking at a vertical asymptote. If you're approaching negative or positive infinity for the limit, then your answer is the horizontal asymptote.